back again with me. This session will be a very short one on the unit step function. Okay, well, I'm going to define what it is. Okay, but unit step function is actually under the topic of singularity function. Okay, well, singularity functions, or another name for it is a switching functions, okay, are functions that either are discontinuous or have discontinuous derivatives. Okay, so we use it to represent a switch, a switching signal. Okay, so the three most widely used singularity function in circuits are: one is the unit step, another one is unit impulse. Sorry, there's no E right here. Okay, unit impulse, and another one is unit ramp function. Okay, right. So these are the definitions of the unit step, which we will use a lot. Okay, in this class. Okay, first U of t, right? Unit step. You can think of it as, well, unit is like one. Okay, and step is like a step up stair. So therefore, the shape of the function is like this, like a step, and a step like unit 1. Okay, so U of t is defined as, unit step is defined as, at t less than 0, the function value is 0. At t greater than 0, the function is 1. And at t equal to 0, it's undefined. Okay, so this is the definition. Well, there's also a shifting that you can do. It doesn't have to be at t equal to 0 all the time to have the step. Okay, so if you want to delay or advance it a little bit, this is the way we write it. Okay, we write it as, if you want to delay it, okay, so normal unit step would start at 0, but you want to start a little later at t equal to 0. The way I remember is that, sorry, but it's delay, right? It's supposed to come at 0, but I come at t equal, it step up at t equal to t0, t0. It's delay. So delay, anyone that comes in late, it's like a sort of like a bad feelings, that not a negative feeling that you are late, right? So therefore it's a negative feeling, so put a negative there. So it becomes u t minus t0, right? And equal to, right? At t less than t0, it's equal to 0. And at t, right, greater than t0 is equal to 1. So this is how the step is delayed by t0. Okay. Another one is, of course, if you want to the step comes before t equal to 0. So it comes in advance. You're supposed to come at t equal to 0, but you come before t equal to 0. You sort of step up before t equal to 0. So at minus t0, the steps start. Okay. So in this case, right, well, you come before. So you come before. So it's a positive feelings. It's a positive feelings, right? So therefore, right, the unit step is, put a sign positive there. Okay, positive there. So therefore, u at t plus t0 equal to 0 for t less than minus t0, and is equal to 1 at t greater than minus t0. So this is the picture. This is all the three so-called functions that you need to know for the exam. Okay. Next one is called the, okay, before I go on, I say why do we need it? What does it mean by it represent the switching? So therefore, for example, if you have a current source, right, this is a switch, it represents as a switch. The switch closes, right, right, at t equal to 0, for example. Okay, this is 5 amps, right, 5 amps. So in this case, what do you have? You would write it down as, well, I would be equal to, at t less than 0, right, it opens, so I would be 0 amp, right? For t greater than 0, the switch closes, right? So therefore, 5 amp will flow. So I equal to 5 amps. So this is with the switch, the picture with switch. What if I change this to 5u of t? 5u of t. Okay, amps. So this is I, still same thing. So for t less than 0, right, u of t is equal to 0. So therefore I equal to 5 times 0 equal to 0 amps. For t greater than 0, the unit step is equal to 1. So therefore, I is equal to 5 times 1 equal to 5m. So same thing. So therefore, that's why we use U of t instead of a switch. Okay. What about voltage source? Voltage source. Okay. So let's see. The switch change positions, right? For t less than 0, okay, for t less than 0, let's say 0, easier to understand. T less than 0, the switch this position, right? So therefore, your V of t is equal to 0 volt. Okay. Then at t greater than 0, right? Your switch move here. So therefore, your V of t is equal to V naught, right? These values. Now about this one. If this is V out, V naught U of t, okay. So therefore, at t less than 0, U of t is equal to 0, right? So therefore, V of t is equal to V naught times 0 equal to 0 volt. At t greater than 0, your unit step is equal to 1. So therefore, your V of t is equal to V naught times 1 equal to V naught volt. So therefore, again here, unit step represent this switch. Okay, so you see my point. Okay. Well, another one that you may need in later on as electrical engineering courses, is unit impulse function. Okay, so pretty much it's 0 everywhere except at t equal to 0, where it's undefined, and this is the definition of the unit impulse functions. Okay, another one is the ramp. Okay, so in this case also, if you have a shifting, right, if this is shift by 1, so it becomes t minus 1, right? It's like delay, and this advanced by 2, so it's t plus 2. Unit ramp, okay, unit ramp's like a ramp, right? Have slope. So therefore, the definition is R of t would be 0 for t less than or equal to 0, like this. But at t greater than 0, right, R of t is t. So if it's t is 1, R of t is 1. If 2 is 2. Okay, so the unit slope is plus t. Again, if there's a delay, right, it has become 0, 0, 0, 0, and then ramp up at t naught, right? So therefore, you would write down as RT minus t naught. Okay, and if it's advanced, come before t equal to 0, you write down at RT plus t naught, like this. Okay, so this is the ramp functions. Okay, so let's look at an example. Okay, let's say that you have a function, let's say V of t equal to U of t minus ut minus tau. Okay, minus tau. So what is it then? What is this? What does this function would look like? Okay, so therefore the way I do is that, okay, to practice, well, we write down, we draw the function u of t, which is, right, at t equal to 0, less than 0, it's 0, greater than 0 is 1, right, in this case 1. Okay, then minus, right, it's minus. Well, t minus tau means it's delay by tau. So therefore, at t less than tau, it's 0, and it step up, right, at t greater than tau, right? So then I start subtracting it. So if it's less than 0, well, u of t is 0 right here, right? This is also 0, so the answer is 0 right here. Between, if this is tau, right, between 0 and tau, u of t is 1, right? Minus, this is still 0, right? So 1 minus 0 is 1, so 1 to tau. And then greater than tau, right? This is, the value u of t is 1, right? And tau, this is also 1, right? Greater than tau, this function is also 1. So 1 minus 1 equal to 0. So it go back to 0. So therefore, this function v of t is that, well, for t less than 0, you know, the value is 0, v is 0. Then at t equal to 0, it's go up to 1, stay there until time tau, then it turn off again to v equal to 0. This is t. Okay, so this is the way it is. Okay. Right, so I think you get some point. Another way you can look at it also like this. Okay, right? So in this case, right, a times a is the amplitude, right? Constant, the amplitude. You have ut minus t naught minus, right, ut minus t naught plus t. Okay, so therefore minus means delay, so this is like the first one, it's delayed by t naught, so a times u of t, so this is the amplitude a, right, delay by t naught, so t equal to 0 until it steps to t at t naught, it step up like this. In this case, you know, the way they say it's plus, right, but it's actually minus, so it's actually like they do it like this, a ut minus t naught plus, right, plus minus a u t minus t naught plus t, like this. Okay, so it's plus, right, they add it, but the minus sign means it's flipped, it inverted, right, so this is minus a instead. Okay, and it's delayed by, right, so this is t naught, this is t naught plus t. At this point it delay like t minus delay by this value t plus t, so therefore when you do it, right, so it's all 0 right here. Okay, so between less than 0, the value here is 0, the value is 0, so therefore less than 0 is 0, right, this is 0, this is t naught, this is t naught plus t. Okay, then between 0 and t naught, right, between this right here, this is 0, this function is 0, between 0 and t naught, this right here is 0, so 0 plus 0 is still 0, this is 0 right here. Okay, then from t naught, right, t naught to t naught plus t, right, this portion, let's change color maybe, these portions, right, this is a, okay, and these portions right here, this is 0, so a plus 0 is a, so therefore you have between t naught and t naught plus t, it's a, the value is a. Then what happened to after t naught plus t? So let's change to purple. Okay, so from here onwards, this is a, right, from t naught plus t, this is from here minus a, so a plus minus a is equal to 0, so it's 0, so therefore this is your what your function looks like. Okay, your voltage turns on at t naught to values a, right, stay there at value a until t naught plus t, and then afterwards turn off again. So this is how you represent, you know, tell you the switching of your circuit, right? So I give you one example right here. Okay, one example right here. So we want to find V of t across 6 ohm. Okay, there's no switch anymore, right? No switch on and off, but given the voltage source as 12 U of t volt. Okay, so first you have to realize, so what is this the voltage source looks like. So with U of t, with unit step U of t, right? So therefore t at t less than 0, it's equal to 0, so 0. At t greater than 0, U of t is 1, right? So it's 12 times 1, so therefore equal to 12. So the voltage source turned on at t equal to 0 equal to 12. So let's start. It's RL circuit, first order circuit. So therefore we can do it step by step, right? Assuming that the voltage that you have to find in this problem, the solution would be in this form. Okay, in this form, K1 plus K2 e to the minus t over tau. We want to find K1, K2 and tau, right? Well, first step, the next step is of course find the initial values for the inductor, right? Inductor store energy. If there's changes in the circuit before the switch changes, does inductor, store some energy in it or not by checking its current going through that inductor. So assuming steady state, right? So at t equal to 0 minus, right? Your voltage is equal to 0, so therefore it acts like a short, correct? Right? Your 2 ohms here, 3 ohms, 6 ohms, this is a value V. And assuming steady state, your inductor acts like a short, so it's like a short, so you have to find IL at 0 minus. You look at the picture, look at the circuit. Well, there's no source or anything, so therefore no IL. So your IL equal to 0 amps. Okay, your IL is that means there's no energy stored in the inductor at all. So this is step is like at t equal to 0 minus in instant. Okay, step 3, right? Step 3 is that at t equal to 0 plus. Well, at t equal to 0 plus, the voltage comes on to 12 volt. So the so-called your circuit becomes like this, right? So 12 volt, 2 ohms, 6 ohms, 3 ohms, inductor. But the inductor, right? We know that inductor is the current doesn't change instantaneously, so therefore IL 0 plus is equal to IL 0 minus. So that means this is 0 amp. 0 amp. So there's no current going through here at this instant at t equal to 0 plus. The steps say that at t equal to 0 plus, right? Find out what the parameter that you wanted at t equal to 0 plus. So V0 plus, what is it? Well, if you say that the current, well, there's a voltage source, there must be current. Currents come up, right? I total. How does it flow? See, you need to know how does your current flows. So go through the 2 ohms, right? Come to this junction. Well, supposedly, it's supposed to go like this and like this, correct? But at this instant, because of inductor property, I is equal to 0. That means there's no current going through here. So we can ignore all this, or the current I total flow through the 2 ohms and 6 ohms. So therefore, you have a mesh, right? You have a mesh. You want to find the voltage across one of the resistor. You can use voltage divider. So therefore, Rx, Vx equal to Rx over R total times Vs, right? Well, we want Rx, the voltage drop across 6 ohms, so Rx is 6, right? V0 plus, V across 6 ohm, divided out from 12 volt right here, the source. The 12 source, give it to whom? The voltage to whom? Divided into amongst 2 ohm and 6 ohm in series, so 6 plus 2. So the answer is 9 volt. So we have V0 plus equal to 9 volt. Okay. Then, okay. Next step, V at infinities. So the circuit look like this, 12 volt, right? Current flow like this, then go here, then goes here, right? But then at infinities, we will assume that it again has reached steady state, right? So the current passing through here will not change anymore. It's a DC signals, DC circuit. So therefore, the inductor would act like a short again. So it becomes short like this. Okay, so therefore, you would have the 2 ohms, right? And you want to find V at infinities. Well, the V at infinities here, right? It's at this node and this node. It looks like it has it's a voltage drop across 6 ohms. That's true also. But you have to also realize that it's between this node and this node, which with these two nodes, another resistor is connected to it, 3 ohms. So in parallel, right? So therefore, the voltage drop here, you have to consider both the 3 ohm and 6 ohms in parallel. So therefore, this is your V at infinities. So again, it reduced to just one loop. You can use voltage divider, right? So therefore, Rx is 2 over 2 plus 2 as R total times the 12 volt equal to 6 volt. So this is your V at infinities. Next step, find tau. It's a RL circuit, so tau is equal to L over R Thevenin. Okay, R Thevenin, R equivalent. So you have to find R Thevenin because we have more than one R, one resistor. So therefore, looking through, short your voltage source, right? Looking through your inductor, right? What do you see? Okay, so you see that 6 and 2 are in parallel, right? So 6 parallel 2, and then in series with 3, right? So it become like 6 parallel 2, 3 ohms, right? Looking through there. So 3 in series with 6 parallel 2, so 9.5. And so therefore tau become 1/3. Okay, 1/3 second. So L over R. Okay, so that's it. So you can write down your final answer, the final solution. V of t would be V at infinities, right, which is 6, right? V at 0 plus, which is 9, right? 9 minus 6, E minus t over tau. Tau is 1/3, so therefore the answer is, at the end, V of t is 6 plus 3 e to the minus 3t. Okay, just to make sure that, okay, it's for t greater than 0, right, this value, so you put u of t back on. Okay, so this is an example of you have unit step, okay, in the circuit, and also you use step-by-step approach. Okay, so thank you.